Hello, 8th graders of Eureka Middle School. Mr. DeShazer here. Here to tell you about your Tuesday take-home, which I think you're going to find is surprisingly easy, and a little bit about dimensional analysis. So you guys are probably viewing this on Google Classroom or maybe through an Edpuzzle right now. I'm not sure what I want to do yet with that, but first off, attached to Google Classroom, there'll be a PDF of these notes on pages, I believe we're on, is it 14 and 15 now? That says 10 and 11, so I'll make sure I change that to 14 and 15 before this goes up. But title pages 14 and 15, Dimensional Analysis. Now, dimensional analysis, it's really an intimidating term when you think of just the words, dimensional analysis, but really all it is I like to say the art of applying or multiplying by 1. Now, as you know, anything multiplied by 1 is just itself. So we're not actually changing the value of anything. All we're doing is converting units by multiplying them by 1, essentially. And I'm going to explain how we do that. I know it sounds kind of abstract right now, but stay with me here, and this all makes sense at the end, I'm sure. So I'm going to zoom in to just the top left corner here. So we've got 3 rules regarding dimensional analysis. Rule number 1, all values must include units. Just a reminder, if you're not sure what units are, they're those letters that are always at the end of, the numbers that we have. So if we're talking about distance, the unit is going to be an m for meters, right? If we're talking about time, it might be in seconds or hours or even days potentially, right? Rule number 2, since physical values cannot change, like I said, initial values can only be multiplied by 1. Notice it's in quotations. I'm going to explain why, because we can make 1 be in a bunch of different forms, really. And number 3, units must be canceled out through multiplying by fractions. I know some of you guys may not like multiplying fractions or fractions in general, but hopefully I can make it as painless as possible to learn about dimensional analysis here. So let's move on and just talk about single unit conversions. So single unit conversions are pretty simple, really. I mean, we've been doing a lot of them when we were just talking about metric conversions, but we had a really easy, quick way of doing that. I might have to go on to the next page here. Here we are, and talk about single unit conversions. So here's an example where we have 40 kilometers equals how many meters? Well, obviously, if we had King Henry died while drinking chocolate milk, we'd be able to figure out that it's 40,000 meters just by simply moving the decimal over to the right. But here is just an easy example of how we can use dimensional analysis to solve this as well. If we know that there is 1,000 meters in 1 kilometer here, then essentially, if we have 1,000 meters divided by 1 kilometer, that's the same thing as taking 1,000 meters divided by 1,000 meters, or 1 kilometer divided by 1 kilometer. So anything divided by itself is always just 1. So this here, this value is really just 1. What's convenient about it is that it has units tied to it. Now, if we have kilometers up on the numerator, the top of the fraction, and kilometers up or down on the denominator, that's kilometers divided by kilometers. Now, when you have a kilometer divided by a kilometer, that is not a kilometer, it is 1. I'll ask you guys this question, and sometimes I can get some laughs out of it, but I'll ask you, what's 5 divided by 5? Everyone says 1. What's 6 divided by 6? Everyone says 1. And I say, what's, a rhinoceros divided by a rhinoceros? And everyone says rhinoceros. No, it's not. It's 1. So just remember that. So that's what we like to do. When we cross out our units, we cross them out like this, and that shows that kilometers is no longer one of the units that we're using. So next, after we do that, we just multiply this straight across. So 40 times 1,000 equals 40,000. There's nothing over here to multiply by the 1, so it's just 1 over here. Notice it's not kilometers because kilometers was canceled out, and that'll give us 40,000 meters. Meters is the unit that's left. Let's move on to another one here. We have 72,000 seconds equals how many hours? Okay, so this is kind of a multi-step conversion here, because between seconds and hours we have minutes, right? So let's start with 72,000 seconds, and we're going to multiply that by 1 minute over 60 seconds. Okay, so if we do that, we'll be able to cancel out our seconds because we have seconds on top and seconds on bottom. Then we'll try to get rid of minutes, so we'll multiply that by 1 hour divided by 60 minutes. Reminder, notice these values are just worth 1. So we'll cross out minutes, and now if you look at the units that are crossed out, the only thing that we're left with is hours. So now all we got to do is multiply across the numerator and the denominator, and that gives us 72,000 hours over 3,600 something with no units, I guess. So whatever our answer is going to be, it's going to be in hours and hours alone. We divide 72,000 by 3,600 and we get 20 hours. Okay? I'm going to keep on moving along here, but you guys can rewind the video if you're getting confused, okay? So we have mixed unit conversions here listed at the top of page 11. Some mixed unit conversions are things such as speed or density. Now we've learned about those two things, and we've kind of learned about the properties and the units that go along with those. Well, we're going to learn how to convert, say, meters per second to kilometers per hour, or grams per milliliter to kilograms per liter, potentially, right? So if we look here, here's an example. It says, how fast is 20 kilometers per hour in meters per second? So this is what we got to do. First, we need to convert one unit and multiply through. So we either choose the distance, like kilometers to meters first, or we choose the time, hours to seconds first. Let's go with kilometers to meters first, just because it might be a little bit easier, and then we'll go on to hours after that. Sound good? So we have 20 kilometers per hour. I just wrote it as a fraction, 20 kilometers per 1 hour. So, you know, if you think about it as speed, you're traveling 20 kilometers in 1 hour. Okay, and if we're going to convert distance here, we will change kilometers to meters. So we have 20 kilometers per hour times 1,000 meters divided by 1 kilometer. Notice this is just 1. 1,000 meters equals 1 kilometer. So this is just 1, but our units can cross out, right? So, sorry, trying to find the right thickness here. Okay, so we have 20 kilometers, cross out kilometers because we have this on top and this on bottom, so we can cross that out. So currently we're in meters per hour. So we will multiply straight across, and we get 20 times 1,000 is 20,000 meters. That's our unit that's on top there. And we have 1 times 1 equals 1 hour. Okay, so now what we're going to do is we are going to convert the next unit and multiply on through. So our next unit that we got to convert is hours to seconds. Hours to seconds. We see that? So I'll try to maybe just draw a line that brings this down to here. And so this value is just this right here. Whoops, I might have to fix that real quick. Sorry. Hold on just a second, guys. There we go. So we have 20,000 meters over 1 hour. And we got to convert hours to seconds, like I said. So first, let's convert it to minutes. So what we do is we write 1 hour over 60 minutes. It's just 1, but we put the hour on top so we can cancel it out. We see that? So we can cancel out hours just like that. And then we can go 1 minute over 60 seconds. We put minutes on top because minutes is on bottom over here. And we can cross out minutes. So now take a look at the units that are not crossed out. We have meters and we have seconds. Now scroll back up here. We need to get to meters per second, right? Meters per second. I think we're good. So now what we can do is just multiply on through. So 20,000 times 1 times 1 equals, you guessed it, 20,000. And then 1 times 60 times 60 is 3,600. So now this is a division symbol here. So we just go 20,000 meters divided by 3,600 seconds, and that gives us 5.56 meters per 1 second, or we can rewrite it as 5.56 meters. So I hope showing you the notes this way was at least a little bit more personal, and maybe at least you can rewind and look back at what I was talking about. I know sometimes when I'm giving notes in class it's hard to pay attention, especially when you're in the very far back. So your assignment for your Tuesday take-home is just to watch this video and get the notes down, including all these unit conversions, these examples, okay? Because on Wednesday I would like to start a worksheet regarding dimensional analysis. Okay, all right, that's all I have for you guys. Have a great day, and I will see you, well, I guess I'm not sure I'll see you because I'm not sure when you're listening to this. But anyways, have a good one.